Right, now we will be looking at the second part of chapter 1, experimental chemistry. Okay, and we will first start off with looking at what are pure substances, discussing them, and also looking at how impurities affect pure substances. Okay, let's first look at the learning objective. So at the end of this section, you'll be able to understand how given melting and boiling point will help us I identify the substances and also determine whether they are pure. All right. We will also be looking at a very short part on the importance of ensuring purity in substances, especially in foodstuff and drugs or medicine. So in everyday life, okay, there are many substances that we come across. Some of them are pure, some of them are not. Okay, what do we constitute a pure substance? This is the definition of a pure substance. It is a substance that is made up of only one substance, and it's not mixed with any other substances. Okay, so this is the key point that you need to take away. All right. However, most of the time, we do not find pure substances easily. Okay, uh, most substances that we see in our daily life, they are impure, which is also known as a mixture. Okay, so an impure substance is actually alternatively known as a mixture. So what's the definition of a mixture? It means two or more substances that are not chemically combined together. All right, so there's no chemical reaction between them, and we have all these examples over here. I'm just going to take two of them to talk about it. Seawater. All right, if you all were to actually think about it, what could be found in seawater? I would say, of course, the main thing will be there's water, but it's also mixed with a large amount of salt. Okay, so that's why seawater is salty. Okay, of course, you have uh, other substances in seawater. You could have soy, mud, and you could have the marine life waste, etc. So all these makes up a mixture. Air, on the other hand, okay, is a mixture, and we did briefly talk about air earlier on. It's made up of 78% nitrogen, 21% oxygen, 1% argon. That's the main three gases. Then, of course, you have other gases like carbon dioxide, water vapor, which are in smaller, minute amounts. Okay, then you could have air pollutants as well in air. Okay, so these are all mixed together. One common misconception is that students always think that hydrogen is found in air, but this is actually not true. Okay, so hydrogen is not. Okay, let's move on. So, how do we know whether a substance is pure or impure? Is it a pure substance or a mixture? You can't use your eyes to just observe. Even a colorless liquid, okay, may look very clean. Okay, if you look at your water in your water bottle, it looks clear, it looks clean, but it may not be a pure substance. In fact, most of the time they are not. Uh, the way to check whether a substance is pure is to either melt it if if you have a solid, or you boil it if you are dealing with a liquid, and you check whether the substance have a fixed melting and boiling point, meaning does it boil and melt at one temperature. All right, so if it does, then the substance is pure, but if it doesn't, then the substance would be impure, which is a mixture. So a mixture does not have a fixed melting and boiling point. It melts and boils over a range of temperature. Okay, to ensure that you have a better understanding of this, okay, right, I actually have a QR code over here. You can actually use your phone or iPads to scan, and you will see some of the data over here. Okay, so I've actually sieved out the data just to bring some point across. So for example, right, if you look at aluminium, Okay, you can see that aluminium has a melting point of 658, boiling point of 220. So given a data booklet, and if you know the melting point and boiling point of aluminium from this data booklet, if you were to conduct an experiment and you realize that the substance that you're heating actually melts at 658, you can actually draw reference and deduce that it could the unknown that you're dealing with is aluminium. So you can use melting and boiling point as a form of identification. Okay. Uh, Other than that, okay, I will also want to draw your attention to wax. Did you notice that the melting point is actually occurring over a range of temperature? It's melting it's melting throughout the temperatures from 60 to 65 degrees Celsius. So this shows you that wax is actually impure. All right, so that is what I mean by the earlier slide. Okay, let's move on. So what do impurities do to pure substance? Okay, so if I say I have a pure substance, okay, then I were to add impurities to it, it will become impure, of course, and we call it a mixture. So the three things that will happen when a pure substance has been introduced impurities to it is that the melting point will be lowered over here. The boiling point will be increased, and these two will now melt and boil over a range of temperature. Okay, so three things can happen. If I were to give you an example, let's say my substance melts at 400 degrees Celsius. Okay, so if there are impurities added, it will lower the melting point. So this substance may start melting at maybe 395. But it's not going to melt at this exact same temperature throughout. It will melt over a range. So maybe throughout 395 to 399, the impure substance will melt. Okay, then likewise, if it boils at maybe 700 degrees Celsius, once you add impurities to it, it will increase the boiling point. So it may start boiling at 701 degrees Celsius, but it will melt over a range of temperature, so maybe to 704 degrees Celsius. So this is just an example of how impurities affect the melting and boiling point. Okay, so to check whether something is pure, this is the way to do it. Actually, there's another method to check whether a substance is pure, but we will discuss it when we do separation technique later on. Okay, so just a last slide over here, the importance of purity in substances. So purity in substances is actually very important because if, for example, if you take a medicine, you would not want your medicine to have impurities which are undesirable, and then you consume it into your body, it can cause you harmful effects. Many of us, in fact, I would say all of us use computer to a large extent actually, and there's actually this silicon chip, okay, that is actually used in the computer. All right, and this silicon chip, right, needs to have a certain purity in order for it to function well. So if it's too impure, then too many impurities on it, then it will not function well. Okay, so with that, we have already completed these two learning points. Okay, so you have already seen how melting and boiling point will give us the identity of the substance by comparing with known data, and melting and boiling point, if they are fixed, they will tell us that the substance is pure. But if they melt over a range, then the substance will be impure. And we just discussed the importance of purity.